Hey Chem6BL, so today I'm going to show you guys a very useful reaction that I personally use a lot, and if you're a coffee drinker or a tea drinker, you will probably benefit from as well. So when you use a kettle to make your coffee or your tea, you put water in it and then you boil the water, right? But if you have hard water, which it depends on your location, here where I live, we have very hard water, which means that there's a lot of magnesium and calcium and other ions in the water. What can happen is precipitate forms when you're boiling your water. And so today I'm going to first explain how that precipitate forms, and then after I explain how that precipitate forms, I'm going to explain how to get rid of that precipitate and clean your kettle. So the next time you make coffee or tea, it's fully clean. All right, let's get to it. So first things first, I'm going to fill up my kettle. All right. So as you guys can see, there's precipitate formed already. And these are the ions that I was talking about before. You can see them floating in the water. So now I'm going to boil the water and show you guys that more precipitate is forming. Check back in a little bit. All right, so the kettle has increased temperature quite a bit. I don't want it to get too close to boiling because then the bubbles will interrupt you can't see the precipitate as well, but if you look closely, you can see the different precipitates precipitating out of solution. All right, so now that you guys can see that with added heat, a precipitate forms, I'm going to explain a little bit of the chemistry behind that. All right, so now we're going to look a little bit more at the chemistry side of this reaction. So when you get your water from multiple sources, as I've shown here, you can collect ions in your tap water. So some common ions are sodium, calcium, magnesium, and others. And when your water comes out of the tap, anything you put your water into, those ions can react with each other and create precipitates. And that's exactly what happens in our kettle. So when you place your water in your kettle, what can happen is the calcium ions react with the carbonate ions and form calcium carbonate, which is also called limestone. And what's interesting about calcium carbonate is that at high temperatures, calcium carbonate becomes insoluble in water. This is a graph I made to depict what happens at high temperatures with the solubility of calcium carbonate. As you can see, it's a little weird because normally we would think at high temperatures there'd be a high solubility, but with calcium carbonate, it actually has a high solubility at low temperatures and a low solubility at high temperatures. And so we can see that at high temperatures, calcium carbonate is going to have a low solubility. So now the question is, now that I have limestone on my kettle, is there anything I can do? And that answer is no. There's absolutely nothing you can do. You will be stuck with precipitate on your kettle forever. Obviously, I'm just kidding. There's a great way to clean the precipitate off your kettle, and that's with vinegar or acetic acid. And over here I have the structure of acetic acid, and then also the version that I'll be using for the rest of the discussion, which is CH3COOH. So now we unfortunately have to do some math. Today we will be using 5% vinegar, which means there's 5 grams of acetic acid per 100 milliliters water. Using the molecular weight, we find that in 5 grams of acetic acid, there's 83 millimoles. And using that over 0.1 liters, we get 0.833 molar solution acetic acid. So now we will look at the balanced equation for this reaction. As we can see, there will be 2 equivalents of acetic acid per 1 equivalent of calcium carbonate. We will heat the reaction to move it in the forward direction, and then there will be 1 equivalent of calcium acetate produced, 1 equivalent of carbon dioxide, and 1 equivalent of water. And this is what calcium acetate would actually look like in solution. Lastly, the great thing about calcium acetate is that it will be soluble in water at high temperatures. So once this reaction is complete, the calcium acetate will dissolve and you can pour out the solution and you should have a very clean kettle. So we will be using distilled white vinegar for this reaction. And as you can see, it's 5% acidity like we talked about. And also, I just wanted to show you guys what the initial product was. So as you can see, all the residue is calcium carbonate and limestone right here. So usually I use about a 1-to-1 ratio of vinegar to water. So that's what we'll be using today. But if you have a particularly hard water, you can use a higher dilution. So my kettle has about a 1.7 liter max volume. So we will put about 0.85 liters of vinegar in the kettle. Now I will fill the rest with water. That's about all. And we will add heat, and it already smells terrible. So it's about halfway through boiling right now, and as you guys can see, the residue on the bottom, the calcium carbonate, has dissolved into solution, and you can see condensation and vapors are evaporating from the solution, which will be the carbon dioxide and the water that was produced in this reaction. So I'll show you guys the end product after it's done boiling. Alright, so it just finished boiling, so now we're gonna take solution and just dump it. And then check it out. Bottom is all clean. And yeah, that's how you clean your kettle. Alright, thanks for watching, guys. Make sure you rinse your kettle out 2 or 3 times with water before using, just to get that excess vinegar out. And yeah, I hope you learned something about chemistry today, and also vinegar as a cleaning solvent. It's actually very environmentally friendly, so it's a great tool for cleaning. Alright, thanks.